Okay, to show you how fast and easy working with these slope fields can be, I wanted to just go ahead and do the slope field problems for the review for them as I would solve them. So I wrote down the steps up here. So the first step is to eliminate variables. And what I mean by that is to interpret the graphs to figure out if there's only an x variable, only a y, or a mix of x's and y's. Then for the similar graphs, let's say I have more than one graph with only an x variable, I would find one coordinate point where they have different slopes, and then I would plug those coordinates into the differential equations to find my final solution. So let's go ahead and do that real fast. So for graph A, it changes with my y values and changes with my x values. So this has x and y. For graph B, it doesn't change with my y values anywhere, but it does change with my x, so this must only have an x. For C, it does not change with my x value, but it does change with my y, so it must only have a y variable. And finally, for D, it does change with my x values, and it does change with my y values, so it must have both. Now that I know that B only has an x value and C only has a y value, and they are my only graphs with only one variable, I can actually go ahead and find those solutions. So I'm looking for a differential equation with only an x value in it. This has x and y, this has x and y, this has only y. 11 has only x. Our slope is 0.5x minus 1, that's the only one. The solution must be B. Done. C is the only graph with only a y variable. This is my only equation. Question 12 is my only equation with only a y variable. My slope equals 0.5 times y. So that answer must be C. Done. I'm almost finished with all of this problem. All four of these problems. So A here and D here both have x and y. So I need to find one spot where they're different. There are lots of spots where they're different. I'm going to pick this point. 0, 1. If you go to 0, 1 on both graphs, the one on the left has an uphill slope. And the one on the bottom right has a straight across slope. So this slope must be positive. This slope must be 0. So I am going to take that coordinate point, which was 0, 1, and I'm going to plug it into both equations that have x and y. One of them has to be uphill, and one of them has to be 0. So if I plug in 0, 1 to this equation, this is negative 0 divided by 1. Well, that's 0, isn't it? Awesome. So 13 must be D. Now, for 14, just to confirm, if I plug in 0 for x and 1 for y, 0 plus 1, that's 1. Awesome. That's uphill. That must be A. And I'm done. In just that amount of time, it's been less than 3 minutes, and I solved all 4 questions using this process.